Hi class, what's going on? So today is Tuesday, January 26th, and I'm a daddy, which is really sweet, but I'm still not back at school with you all. So we started a new unit yesterday, and you guys had some notes that you took down based on the PowerPoint that was shared with you. And those are going to be the baseline for this unit. So the information that you need to know or that will help you understand what we're trying to teach you will all kind of boil down to what's there. And after you finished that yesterday, there was an assignment on a phenomena, which is basically something that happens in nature that doesn't seem normal or natural, but that can be explained through investigation and through the understanding of science. So hopefully you worked on both of those yesterday. Today, we're going to talk more about this phenomena known as conservation of mass. It's also known as conservation of matter. And a lot of the time, the way this is described is that matter or mass cannot be created or destroyed. So it has to go somewhere. The mass or the matter is always going somewhere. It may change. That's the key, is that matter and masses change. We just talked about physical and chemical changes, but it doesn't necessarily go away. So while there might be situations that look like the matter disappears, like a magic trick, it actually is somewhere. We just have to know where to look. And understanding science and how nature works and chemistry works is kind of where we understand what actually is going on. Okay. So we're going to learn about that in this unit, and then we'll be able to explain ourselves and understand how this phenomena takes place in our world. Okay. So the first thing I want you to do, and there's really no right or wrong answer, I just am trying to see what you think. Because when we start talking about this phenomena, we're going to start discussing open systems and closed systems. And the way we understand each of those two systems is going to help us determine where this mass is going and explain it in terms of um, where it is and if it's useful or not. So I do want to know what you think those could mean. And please try not to Google this or look for it. I'd love for you to actually try and answer this on your own. Obviously, Google knows more than you because it's literally a bunch of minds put together on the intranet. So it's not really something that's known. It's more like facts. I want you to understand. So we want to see what you think so we can help you understand, right? Not just what, but why. And that's really what we're trying to do in science. So the first part of this page, it's basically two worksheets that I put together, but I've given you the answers for the first part. And then I want you to try and finish the second part on your own and see if you can apply some of the things that we are learning. So after you answer the open and closed system questions, you're going to start with the scenario or situation that we're working on. So number one says a pupil, and that's not someone's eyeball. That's like a person who's studying underneath a professor or scientist. It says a pupil heated 1.25 grams, so that's a solid, of copper carbonate strongly. The chemical reaction which took place is represented by the equation. And down here, we actually have that equation. And so while we're not going to necessarily go into the detail you will in high school or even maybe in 8th grade when it comes to these equations, I want you to see them. So you basically can understand it's an equation because we have everything on this side, the left side, equals everything on the right side. And so you can look at this arrow kind of as an equal sign. They're just in different places, right? So if I count this up, I got Cu, Cu, and one of those, and I have one carbon and one carbon, and I have 3 oxygen and 1 oxygen here and 2 oxygen there. So the same, it's equal on both sides. That's why it's called an equation. And there are different ways so many things in chemistry with high schoolers that are interesting with these equations. I just want us to understand they exist and to know two things about them. One, what are the reactants and what are the products? So the reactants are the things that react, so it comes first. And then when things react, they produce products, right? They make something. So you think about a product as something that's made, that's what you get at the end, and a reaction happens before. So there's a note here, just so you can understand these reactions, is that in chemical reactions, an S stands for solid, G stands for gas, L for liquid, and AQ for aqueous solution. And so that aqueous solution would mean that there's like Kool-Aid but dissolved in water. So sometimes we have solid Kool-Aid, and sometimes we have liquid Kool-Aid. We know that that's the same stuff, right? We just have we have water with it. So that's what that means in a reaction, if you ever see those things. This helps us understand the state of matter in chemical reactions. And then we can use a scale to see the mass before and after a reaction takes place to help us understand where mass goes, which is really what we're learning, is what is going on with mass. How can we make things disappear? Because technically in nature, we know that we can't. Okay. So it says after the solid which remained had cooled, he weighed it, and he found that its mass was 0.8 grams. So we started with 1.24 grams, and after this reaction, we had 0.8 grams, right? Started with 1.24, and now we have 0.8. And so we could think, oh my goodness, it disappeared. But the reality is, and you look at the reaction, you can tell it did not disappear. We had a mass with everything in it before the reaction. Now we have two different chemical compounds, and one of those is not a mass. So it's not going to be able to be weighed like a solid would. You could still weigh it, find the mass of it, but it would be more difficult. So why did the people find a decrease in mass in this experiment? Because the solid had lost some carbon and oxygen in the form of carbon dioxide. The solid no longer has a carbon and two oxygens. It's over here in carbon dioxide. And that mass had existed in the gas that was produced. So this is the mass of these, what's been taken away is in the gas, no longer in the solid. So while it looks like you are on the best chemical diet for chemicals, not that chemicals are humans, that's a really weird way to think about it. While it looks like they lost a lot of mass, it's actually just in a different form or state of matter. It's in a gas. So if we could find a way to weigh the gas, we could actually show that the mass is the same and there hasn't been a change. But that all goes back to open system or closed system. Okay. He then heated the 0.8 gram solid again. When he lifted it after cooling, its mass was still 0.8 grams. Explain why it had not changed in mass this time. Well, if we look at our reaction, there's no carbon dioxide that can come out of this, right? And there's not enough oxygen for it to make even just O2 or a different gas. So heating it a second time didn't produce a reaction. So the mass simply stayed the same as it was after the reaction. There's no more carbon dioxide that could be made. So we are not going to be able to make more because we used it. It's all out there in the gas now. So in order for that reaction to happen again, we'd have to have more. And we don't have that. So in another experiment, he burnt magnesium ribbon in air. He found that the mass of the powder formed was greater than the original mass of the ribbon. Explain this. The trick in this is that it makes you think, oh, it's just magnesium. But if you read the sentence, it kind of gives a clue to where the extra mass came from. Right? It says, in another experiment, he burnt magnesium ribbon in air. Right. Lots of times we forget air because it it's clear, and we don't have to think about breathing, so it can affect us. We don't understand, hey, oh, there's oxygen there, kind of important, a little bit of a big deal, right? Well, what happens is the magnesium ribbon reacted with that air, okay? And the oxygen from the combustion, which is a chemical property. So we had a chemical reaction, that flame was given off, but that reaction made a new substance, right? We know that's what happens when you have chemical reactions or chemical changes. Something new is made. So the chemical that was made had magnesium and oxygen from the air. And because the extra oxygen is there in the solid now, it's actually going to weigh more. So it's kind of the opposite of the last scenario, right? Now there's oxygen from the air that's coming to the molecule, and it's making it weigh more, okay? So if I look at a balanced equation, so this is kind of hard, and that's okay, but we do want you to understand how to write an equation and where the products and reactants are, and kind of where is the mass, and it really helps us do that. There's something called balancing reactions, and I know that's kind of in there. But we're not going to do that in 7th grade, but you will learn about that in 8th or 9th grade, most likely. Okay, so here's our balance reaction. In blue, there's some notes to help us understand. Right? It says Mg stands for magnesium, and O2 stands for oxygen in the air. And this actually should be a smaller little number too, but I was having trouble getting my computer to do it, and it's okay. A balanced equation means that you have one side of the reaction will be the same as what you have on the other side, but in a different order, right? So that's in words now here on your paper that I described that earlier when we looked at the other reaction. So we have the same thing, same objects we're talking about, but they're rearranged, right? And that's what happens when there's a chemical change. You change how things are put together. It doesn't mean that they're different, they're just put together different. And the left side here is called the reactants. Those are the things that react. And the right side is called the product. And those are what is made or produced in a reaction. So if you can remember that, hey, in chemical changes or reactions, we produce something, we make something, and the things you make are products because that's what you produced. Then the reactions are what you need before, right? They're the things that act again, right? So, and they act together to make something new. So this is what that would look like. We have a magnesium solid, and then the O2 gas. So we said magnesium ribbon, and there. And then it reacts, equals. Now we have magnesium and air together, and then I put plus heat. You don't always see that in reactions, but if we were to see this, which I actually think we could demo for you in class if we prepare you for it, then we would actually see a lot of energy being released, and we know that energy is really just heat. It just might look different. It could be electricity, it could be flame, or it could literally be like touch, like heat. So anyway, these are all examples of how mass is conserved in a chemical reaction, or what we've been calling chemical changes. Because the mass you start with is going to be the mass that you finish with. It just may not be in the same place. And so we have to determine if it's in a place that we can use it, or if it's in a place that we can't use it. And that all kind of depends on how we want to define our system and create a system that allows us to keep everything, or a system that helps us, sometimes our goal is to get rid of things and focus on what's left over. So it just depends, right? After you type in these answers, which is what I want you to do, the things in red, I'd like you to actually put those in your assignment so that I know that you've done this and watched this video. Then you're going to work on the second part on your own. And so these are similar situations, and really it's to prepare you for tomorrow's assignment. But you're going to basically answer these questions on your own, and that's kind of what I'll look at and we'll talk about as a class before we really get to a point where we're going to quiz over this little unit. So When I get back, we should have a lab for us to do. Before we do that, when you look at this first question, it says when carbon burns, it combines with oxygen to form carbon dioxide. The diagram shows some carbon atoms reacting with oxygen molecules. So this is carbon, and this is oxygen, and this is what's made, CO2, carbon dioxide. Okay. It says the first question here says finish the diagram by drawing the correct number of carbon dioxide molecules. One has been done for you. This is actually not a picture. It is a drawing. So if you click on it, it will open like this, and it will show a drawing. And you can physically, if you wanted to, you can take like a pencil or a tool. Like I can go line, I can go here, and I can go scribble, and I could actually draw whatever I want to draw in here. So what I might do is, I might go, okay, here, and then here's this, and here's this, and then I might label this C, and this O, and this O. So you could draw it, or you could like find a way to, copy and paste this picture in there if you want to. But basically, you're kind of showing the balanced equation. Remember, whatever has mass over here with the same mass over here. So I need the same amount of stuff on both sides, right? And so what I need to do here is kind of undo. So then I'll save and close. But you can go in there and actually change that drawing for your answer for A. For B, you're going to write reactants and products under the correct sides of the diagram. You can also do that in the drawing. So, and you can insert a text box on these lines in the drawing that's above. C, you had 12 grams of carbon reacted with 32 grams of oxygen. It says what mass of carbon dioxide was formed. You need to decide which one of these is your answer. Instead of circling, you can highlight. And I will just change that in y'all's document. Highlight the correct answer. And then, so number 2, you have a different reaction. It says that this diagram shows the reaction between marble chips and acid. This is the word equation. And so instead of the symbols, we just have written words. Question A, is carbon dioxide a solid, a liquid, or a gas? You should know the answer to that by now. B, what would you expect the balance to read when the reaction has finished? Circle the correct answer. Again, I'm going to change this to highlight the correct answer. And then explain. You can do that in your own words. So you're going to tell me why you chose, just a why question. Anytime you see explain, it's why. Why'd you pick that one? Why didn't you pick the other one? Like if you say both of those things, it'd be great. Number 3, if you heat a piece of copper, it combines with oxygen from the air to form a black layer of copper oxide. So this is similar to our magnesium situation. Write a word equation for this reaction. All of your things you need to talk about are, you have copper here, and I'll underline it. Then you have oxygen, underline, and then you have copper oxide. So those are your words, and you're going to put them in an equation. So instead of doing symbols, you do the same thing, but with words. It means that I should have copper and oxygen in one place and a different place on the other side. That's all you have to do. And then B, how would the mass of your piece of copper change based on this as you heated it? And then C, why would this happen? So explain why the mass would change. Okay, so this is practice to see if you get it based on what I just went over with you. Hopefully this kind of helps. After notes yesterday, maybe you just did the assignment and you didn't really get much out of it today. Hopefully you're having to think a little, and we can see what you truly get from your time here. Please use headphones and listen and do this assignment genuinely. Tomorrow you'll have another assignment. We're going to use a PhET lab, which I know is not some of y'all's favorite, but think of it as an activity to help you understand. So I'm going to give you an assignment. It's what you should be working on for the sub, but I'm not going to take some kind of harsh grade on it. I probably won't even grade it, but I do want you to do it so you can learn. All right. See ya. Bye.